Oh, hey, what's happening there, YouTube? It's Brian House here for Housemade, and this video is the essential quick start guide to building the Revolution Gen 5 kit. It's to show you how quickly and easily you can get your machine fabricated and up and running. No fluff, no frills. We're going to focus only on the welding portion of this, and hopefully this gets you guys grinding as fast as possible. Now, if you're interested in this project and you don't have our kit, make sure you go to our website, housemade.us, and check out the Revolution project. It's a big, heavy-duty industrial machine that you build yourself, and it will revolutionize your workshop. Let's get started. Okay, so step one of this process is to clean and prep your steel. Even though the parts have been fully machined, they are raw tube steel, so you're going to want to remove the mill scale. There is a quick, non-toxic way to do this, and that's using household vinegar. You can pick this up at a grocery store or a Sam's Club, grab about 4 gallons of it in a 5-gallon bucket, dump your parts in, and let them soak for about 48 hours. Once 48 hours has passed, you can neutralize the acid with some Windex, dry them off, and spray them down with some WD-40. Now, the WD-40 is an oil and it will smoke when welding. However, it will not contaminate your welds. So we're going to go ahead and start by following along with the Revolution plan set. This is a printed version. You can buy them printed, but when you buy the kit, it comes standard with a PDF version that you can pull up on a phone or a computer. I highly recommend that you look at the plans as well as this video while you're building this machine. And in the fabrication portion, the first step is to build the receiver tube assembly. And this is really quite simple. And we're going to go ahead and grab our receiver tubes, clamp them together, and get started on those welds. The orientation of these tubes looks like this. There's a tapped hole about 1 inch in on one end of each tube. And you just want those opposing each other, right? So it looks like this. What we're going to do is we're going to clamp them together. The way I like to do it is use a couple of cant twist clamps and put it right in the middle, and one clamp putting pressure straight down. Now what we've done here is we've essentially pinched together the two tubes and then applied down pressure with a C-clamp to our work table using a hinge to evenly distribute that pressure. Also, this is a welder's hack. You can use butter spray from the grocery store as anti-spatter. Yes, it works. So when you're done, this is what your part should look like. Got these welds on both sides, and your tapped holes are opposing each other. Okay, so the next step is we are going to build the tracking pillar. This is another simple process. So we're going to grab the tracking pillar itself and the spring tab. We're going to line up the spring tab inside of this 1/2 inch hole back here. And the goal is to really just match this angle with this angle. And I've kind of gotten lazy over the years and just go ahead and eyeball it and throw a weld in there. And if it's not quite straight, hit it with a hammer, straighten it out, make it work. So now that we have the receiver tubes welded together and the tracking pillar all welded together, we're going to go ahead and marry these two parts together. And the tracking pillar goes on the opposite side as the drilled and tapped holes. And I don't bother to measure too much around here, but it's about a 1/2 inch or so, you know, say 12 millimeters, something like that, from the back end of these receiver tubes. I'm going to lay them flat, and then I'm going to use the motor plate as a clamping device so that I can put equal pressure across all surfaces. And I'm not going to go weld crazy on this. I want you to understand something. You do not need to fully weld these parts. 4 good strong tacks in each corner and a 1/2 inch long weld bead along each one of these surfaces is plenty strong. So when you're done with the assembly, you can see this is what it looks like. Welds on both sides, nice and strong. Beautiful part. Okay, so now we're going to weld on the motor plate, and I cannot stress this enough. We've had a bunch of people weld this plate on to the wrong side of this assembly, so pay attention to this Orientation in this particular instance is super important. You can see here where that motor plate is welded to, and I am going to set the motor plate on like this, okay? This is the correct orientation, okay? And so if I were to say stand up this assembly and look at it face on, the motor plate is welded to the right side of the assembly. So how I align this is I've got my motor plate on the right side of the assembly, and I am just lining up the top of the motor plate with the line that's in this receiver tube on the upper right here. This is just an easy reference line. I put a C-clamp down, clamped it to the table on the forward portion of the motor plate, and then I'm gonna plug weld this hole right here, okay? And then we're gonna go in sequence in an X pattern. Plug weld, plug weld, plug weld, and plug weld. Now that we have all 4 plug welds in place, I'm gonna put 3 half-inch weld beads down along the bottom edge and call it good. And this is what the assembly should look like once you're done. Okay, so grab your base plate, set it down on your work surface, and your 2 risers. These risers are different. One has a drilled and tapped hole, as you can see, and the other one does not. The one that does not goes in the rear. And so we're gonna go ahead and place that one in the rear, this one in the forward portion. And just be aware that these curves, they need to go to the right of the user. So this is the front of the machine. The front of the machine has a drilled and tapped hole, okay? And then there's a curve to this, and that curve should be to your right. So if I turn this around and I'm the user and I'm looking at this, I now can see that curved portion of the riser is to my right and the drill and tapped hole is facing me, okay? It's like this, all right? Orientation is important here, and if you mix this up, you're gonna have to cut it apart and start over. So make sure that you're referencing this video and the PDF plan set while you're doing this operation. Next, you wanna grab your big old axle bolt and slide it through. What this is gonna do is it's gonna help stabilize the top. Some people have made spacers to align the top. I don't think it's necessary. If you take your time, you can do this process pretty easily with just some welding magnets. All right. So you can see this is my configuration. What I'm striving for here is to ensure that this bolt stays somewhat freely moving. Once you start welding this, these pillars are going to want to start to warp slightly, and that is something you really need to pay attention to. So we're going to weld these in place, but we're going to do it with opposing tack. So a tack here, and then we're going to oppose the tack on the other side, so in an X pattern. And we're not going to try to pump too much heat into this assembly. Heat will warp this base plate here, and it will cup up. So you really don't need to go weld crazy. I can't stress this enough. A lot of guys put a full weld bead all the way around it, and then they warp their base plate, so their base plate cups up. Totally not necessary. And if you decide you want to do it, just know that you're going to be straightening this base plate out. Even if you clamp it down, it's still going to warp. So just like in the tracking pillar, we're going to put 4 tacks, 1 in each corner, and then a 1-inch weld bead on just the forward and the rear. And that's plenty strong to hold this thing together. Remember, we're not building a skyscraper here, we're building a grinder. Okay, so we know we did it right because this bolt spins freely. This is what your part should look like once you're done with this assembly. Now next we need to thread on the hinges and the shims that go between. There's a nice diagram here in the plan set that shows you how to do it. And remember, the head of the bolt goes to the back of the grinder itself here. So that's the head of the bolt there. I'm gonna pop this out. Start with one hinge. Remember, the flat side of the hinge should be to your right. So if the head of the bolt here, and when you slide it on, the flat side like this should be to your right. The angled part should be to your left like this. All right? So we're going to put the hinge on, non-slotted. Then we're going to put a shim on, slide it through. We're going to put a shim on, put another non-slotted hinge, then another non-slotted hinge, a shim, one more shim, and then the slotted hinge, okay? Just like that. And grab our big old nut, nylock nut, and thread it on. Grab yourself a couple of big old crescent wrenches and tighten it down. Not too tight, but just tight enough to where it will stop these outer hinges from moving. Okay, so now we've got our motor plate, receiver tube, tracking pillar assembly, and we are going to marry these two parts together. The best way I've found to do this is just lay it down on its side and line up the top of these hinges with the line on the side of this receiver tube right here. Makes it super simple to kind of get everything lined up. And the beauty of this axle bolt is that it's holding these hinges in place, so the forward hinge and the rear hinge can be welded and they're going to be in the right spot. So that's a good thing. Now these two center ones are a little bit loose, so we're going to need to just make sure that we hold on to those while we put a tack weld in the top of each one of these hinges. Now that we've got those 4 tack welds in the top of those hinges, we can actually take the machine and stand it up. Now we've got a couple more welds on this. I'd like to actually fill in this little crevasse here and a couple other welds on the top of these hinges and the bottom of the hinges. So let's go ahead and do that. At this point, we're going to check for level using our digital level. If you don't have one of these, they're fantastic for fabrication purposes. And what we're looking for is 90 degrees and 0 degrees on the grinder head itself. So what we're going to do is we're going to take the digital level, we're going to zero it out on the base plate. That will give us our index. And then we are going to set it up top and just see, does it match? And it does not in this case. We're about a degree off. And you can see if I just slightly adjust the head of the grinder, I can get it pretty dang close, right? So we've got a little bit of a discrepancy there. Great news is it's so simple to fix this. What we're gonna do is we're gonna open up the grinder like this, and on the back pillar, we're gonna put a little tack weld, just a little tiny zap right here, and then we're gonna reposition the head and check it for 0. Now, if it's over, we can grind that tack weld back, or if we need more, we'll just add a little more. And then it'll be 0 and 90. Okay, so now that we've got the main grinder built, we're gonna move on to the tracking arm. You'll see here the holes on the side and the top. This is the forward portion of the tracking arm. You're gonna grab your 1-inch cube. Now you might have to grind this down to get it to fit down inside of this tube. We put a little chamfer on the edges there and ground it back. It needs to protrude about 1/4 inch, and then you need to align the handle over it, and you're gonna weld this whole assembly together. Remember that orientation matters in this case. The handle needs to be to the left of the user if you're facing the arm itself. A quick way to know that the orientation is correct is if you see this threaded hole in the top of the tube itself. And that is the top forward portion. So now that it's all set up, we can weld around the face, grind it back flat, and mount it to the machine. And next we're going to build the tracking knob. This is a simple setup. We're gonna grab a 3/8 inch washer and a nut, 3/8 nut. These are provided in the kit, and that's gonna provide the support for this piece here. Give yourself a little room to weld there. Mount this in a vise. Weld and grind back flat. Okay, so now that we're done with the tracking mechanism parts, we can bolt them up to the machine for safekeeping. Let's grab the platen arm and the spacer and line up the holes on one side, doesn't matter which, and put a weld in the back of the spacer itself. Now let's fab up the platen backer. So you're going to grab these parts here and a vise, and we're going to weld them together. Don't worry too much about alignment here. You can manipulate that later. Check them for square. That one is a little off. It's just risen up just a little bit. Put that in a vise and bend that into place. That one's good. And that one's good. So now using the provided hardware, we're going to bolt these two guys up to the D plate here. We're going to use a welding magnet to position these parts in a perfect 90 degree, and then we're going to weld the platen backer all together. For added strength and rigidity, you can weld the other side of these. Just be careful to not overheat the part. Okay, so we have to mount the D plate and the platen backer to the machine so we can get the work rest all lined up. Okay, so we're going to make the work rest receiver setup. It's just these two parts. The orientation here does matter, so make sure you reference the plan set when you go to do this. Essentially, it looks like this when it is completed. So we're going to flip it over, lay it down on something flat, line everything all up, clamp it into place, and lay some stitch welds in the back, flip it over, and weld the front as well. Okay, let's bolt that assembly to the work rest arm. We have one more thing we need to weld on, and that's this little piece of tube steel, and it goes on the bottom of the work rest plate. I have diagrammed this location out in the plan set, so let's go ahead and measure that and draw it out. Step one of this process is to go ahead and zero out your digital angle finder on the arm of the platen, and then ensure that your platen itself is set to 90 degrees. If it's not, adjust it or get it close. Okay, so we've got this all bolted up. We've got our adjustable handle in, and we're going to slide our tube steel into the receiver and lock it into place. Okay. And then what we're going to do is we're going to zero out our digital angle finder on the tooling arm, the work rest tooling arm, okay? And then we're going to set it on top of this tube steel. And we want this to read 0 as well. So we're going to go ahead and adjust this to 0. So now we're ensuring that this surface and this surface are parallel or collinear. Now we're going to grab a welding magnet and our work rest plate, and we are going to line up this square with the top of this tube, or at least get it close. A couple things I want to ensure is that you've got 90 degrees off of the work rest face and the platen on both sides, and also that you have an equal distance in the opening on the top of the work rest plate against the platen. Then you can clamp everything down and perform your welds. Most people report having about 4 hours invested in the fabrication portion of building the Revolution, and if time is money, this is time well spent. Trust me when I tell you, I fully believe that every workshop should have a 2x72. Whether you buy from us or another company, there are so many ways to put this tool to work in your workshop, and you'll wonder why you didn't have one sooner. I truly appreciate you guys for following along with all the support and everything, the likes, the subscribes, and the comments and everything. Thank you, thank you, thank you. You have revolutionized and changed my life. So thank you so much, guys. I truly appreciate you. Hope to see you in the next video. My name is Brian House, and this has been House Made.